Okay, after we have recalled back what you have learned in your Form 2 graph of function, that is the types of the relations. Now I'm going to go through the real syllabus in your Form 4. That is, the first is the function notation. This is the one that most, seriously, the most people, they will say that why is the notation like this? Okay, very easy. So now we go back to the arrow diagram. Okay, we go back to the arrow diagram. You can see, okay, the arrow diagram. Now I write a little number here lah. Okay, so I write 1, 2, 3, easy one. So I just let this function to be +1. Okay, so here will be 2, here will be 3, and here will be 4. Okay, then we link it. Okay, so that's more. Okay, so that's another important part that I haven't done. What's that part? That is the set x and y. So x, y. Okay, so you see this. So we say that. Okay, I will say that this actually is the set y is related to set x with a function. So this is like we describe the function in words. Now how do we describe the function mathematically? Okay, mathematically. So mathematically, of course, using algebra. Okay, algebra. So you see this pattern is just +1, +1, +1. It's just +1. So if you add an x here, this is unknown. You don't know. Either what real number also can, like it can be a 1/2, you can be like 3, you can 3/2, never mind one. So just like here it will be confirmed is x +1 lah. So you link to this. Okay. So we know that this pathway, or we call this process, is called function, right? So I say set y is related to the set y is related to set x with a function which is defined as +1, or we say at 1, more professional at 1. Okay, so this is how we describe a function in words. That mostly I don't think it will appear in our exam paper, but never mind, just for your information. So how to convert it into mathematical way? Okay, so mathematical way, we need to relate it with the function notation. Okay, so the function notation, so for this just for your information, notation is the something that is made by the mathematician to simplify their words. They don't want to use two, like a function of x. There's too many words already. They want to simplify it. So they use a certain alphabets or 2号我电话响了嘛? So for your information, notation is actually the creature made by the mathematician to simplify their work, and the long words like function of x. See, so long the words. So of course they want to simplify it and shorten the words. So they just use a certain alphabets or certain rule to describe the function. So how do they describe? So the first way to describe is very easy. So you can see the process is +1, right? F is +1. You can see here. You can see here f is +1. The f is +1. But when we rewrite it, we say that f of x, okay, f dot x x approaching, that is x +1. So what does it mean? Okay, so actually this arrow is actually originated from this arrow. Both of them are the same. And then the f of x, this f of x is just originated from here and here. So they combine together, they become f dot x. Just not to be confused. Okay. Then the x +1, actually you can see it's an image here. Okay, it's an image here. So after that, the mathematician say that it's kind of wrong also. So I'm going to more simplify it. How to more simplify it? They become like f bracket x equals to x +1. This does not mean f times x. Okay, so this does not mean f times, or we call multiplies. x. Okay, so fx, this thing, is definitely the notation only, the notation of for function. So maybe you ask, if the alphabet, if the letter we must always be f. No, actually does not. You can use any letter. Yeah, you can use any letter for this, for replace x. For example, the most common one, you can say gx, u of x. Okay, gx. You can say hx. Okay, this is the most common one. The common way of writing. But you can actually have many ways. For example, you can like also yx. Also can just use any letter. It just represents function of x. Okay, okay. Just to confirm that you understand what have I said, that function. Let's recall back. Okay, the function is actually the process, right? So the process, as we using mathematically way, you can see fs is equal to x plus 1. What is x? X represents any number you can put inside, but chances higher x should be real number. So x can be any number. You can say that 2, you can say 3, you can say 4, 5, 6, 7, 8, 9, 10, infinity numbers. Okay, so you can see this. S is like a general formula. Fs is like a general formula for this function. Okay, the general formula for the factory to work out, right? So like a robot. Like a robot, you need to give him or give it some order, some way to let it to function properly, right? So there's something like function lah. So the way you're giving it. So this is the general formula is x plus 1. So function is actually very useful. Where is it so useful? Okay, for example, normally when you want to find the value of normally you need to write that is that if I give you a function, it is like if you want to find the value of y of f of x, you need to write like when x is equals to 1, y equals to right? But when you have fx, we do not need this anymore. We just need to write f1. Okay, so what does it mean? Okay, so it means the function of 1 is that 1 is put inside the function, and then we need to find the outcome. So the output is f of 1 is the output. So right now you can see is f of 1 according to this arrow diagram. The f of 1, the 1 after being processed, there is 2. So f1 is equals, so f1 is basically equals to 2. Easy? So from here, okay, so you know this, so we continue lah, okay? So we continue like f2 is equals to 3 and f3 is equals to 4. Right? Then we are going to prove our formula, our general formula, which is fx equal to x plus 1. So I say that x equal to x plus 1. Try to plug in the number. Like now, f1, 1 plus 1. Okay, you get the number of 2. It's the same. Plug in f2. Then you get 2 plus 1 equals to 3. Oh, you got it right again. And then f3, 3 plus 1 is equal to 4. Oh, it's the same. So actually, the s plus 1 is like, don't think it's too hard. It's just the order asks you to plus 1 for the object. Okay, so you know x is the object. So object plus 1 coming out, function of x is the image. Okay, this is what we call function notations. So function notation, basically there's a lot of functions you have learned. Let's flashback again. Okay, the from 2-1 you learn quadratic, linear, reciprocal, and also cubic. So I'm going to do some simple thing for you all. Okay, alright, now fx is equals to x, fx is equal to x squared, fx is equal to x cubed, fx is equal to 1 over x. Okay, so this is what the first one is what we call linear. The second one is the quadratic. and the third one we said is a cubic. And the one that is the public one that is at the denominator, but it's called reciprocal. Okay, so this is some flashback. Okay, so from here you can see when we are writing function, just write function fx equal to 1. But this is one thing for reciprocal function. Okay, reciprocal function is very important. Okay, reciprocal function, there is one thing that you need to write. That is, when you are writing the reciprocal function, for example, I just write a simple one, 1 over x. You should write that x cannot be equal to 0. Why? Because normally I say x, normally we assume it can be any real numbers. But for reciprocal, you cannot plug in x 0. Why? Because we know that 1 over 0 result in undefined, or we call infinity, right? So this is what we need to write. So mostly I can do some example question for you all. That is the SPM example. Okay, so the example 1 is that I give you a number like fx, I give you a function fx equals to 1 over 2x plus 1, where x could not equal to k. K is a constant. Normally we use k as a constant or m as constants, okay, for information only. Okay, so I want you to find the value of k. So this is the example questions. So I say s cannot equal to 1. Okay, so I do a little bit analysis about this. So s cannot equal to 1. Why s cannot be equal to 1? So you need to interpret this. This is interpretation only, teaching only. But when you are doing the real exam question, don't do like this. So s cannot be equal to k. So there's a reason why s cannot be equal to k. There's only one reason for function is the undefined. You will undefined. So when the thing become undefined, that is the denominator always. That undefined occurs when the denominator. So what is denominator? Okay, denominator is like 1 over a. The a is the denominator. Okay, a is the denominator, equals to 0. Okay, this is the first undefined situation. There's another undefined situation later. I'm going to say that. So that x cannot be equal to certain number, that because this certain number causes this function becomes undefined. So the undefined way is to so the undefined occurs when denominator equals to 0. So it means that when 2x from this function, 2x equals to, when 2x equals to 0 is undefined, right? Then we kind of plug in this number 2k negative 1 k equal to negative 1 over 2. You just sub the k inside the x. So from here, what can you conclude? That when x equals to negative 1 over 2, the image will result in undefined. Okay guys, thanks for watching, and please subscribe to our channel called Edu Summer. Let's build a brighter